Let's jump straight in. Alrighty, everybody, let's go to our first keynote speaker. A big warm round of applause for Thierry Carrez, leading open source upstream strategy at OpenStack, and he's going to give us a talk titled "The Open Source Cloud: The History and the Future of OpenStack." Welcome to Athens.
Thank you.
Thank you.
Hello. You can all hear me, right? Okay. So I'm very happy to be here in Greece for this open conference dedicated to cloud and Python. I've been working on open source cloud framework for 10 years now, and I'm also a Python Software Foundation Fellow, so it felt appropriate to come here and talk about an open source cloud framework. Cloud framework that happens to be written in Python called OpenStack. So today, I'll talk to you about the history, how OpenStack came about, how we, what we ended up building, what we learned along the way, and what are our current challenges today. So first, the origin of OpenStack. At the origin of OpenStack was Rackspace. Rackspace is a hosting provider based in the US, and they had a cloud offering named Cloud Servers and Cloud Files. So Cloud Servers was for VMs as a service, basically, and Cloud Files was object storage. And they just completed rewriting Cloud Files, which was originally written in PHP. They did a transition and rewrote it in Python. And they were considering starting the rewrite of Cloud Servers as well, and also considering releasing under an open source license the whole thing. Back then, you have to realize that the field of play back in 2010 was pretty simple. You had VMware basically owning the private infrastructure space. The only player in public infrastructure was Amazon Web Services. And there was one project, open source project, that did try to emulate the Amazon AWS APIs, which was called Eucalyptus. At the same time, there was a team at NASA that was working on deploying Eucalyptus for their private cloud needs. And they were running into trouble with scalability issues with Eucalyptus. So they identified problems in the code, and they started writing patches to fix those scalability issues. And they proposed those back to the Eucalyptus open source project. But one thing you might not know is that Eucalyptus was open core, which means that there was a company behind it that was only doing a community version of Eucalyptus with the base functionality, and every enterprise functionality would be sold in a proprietary version by Eucalyptus systems. So when that team at NASA proposed those patches to basically fix scalability issues, they realized that scalability was an enterprise feature, and that they could not submit those patches onto the open source project, and Eucalyptus systems rejected those patches that would fix the scalability issues in the open source version. So at that point, they basically said, well, screw that, we'll just rewrite the functionality we need from Eucalyptus in Python, and they wrote a proof of concept to do that called Nova. And that's where OpenStack was born. OpenStack is basically the convergence of those two projects, the rewrite of Cloud Servers and Cloud Files by Rackspace, and the project that NASA had for cloud computing fabric. And the thing is, from the day zero, you had those converging interests of serving public infrastructure, the needs of Rackspace, and private infrastructure, the needs of NASA. And it was very essential that we would be fully open source and not open core, because NASA was burned with the Eucalyptus story. So from that beginning, we wanted to start with a very strong set of principles that would define exactly what we're after. And so open source, not open core, is the first principle that we set out. But beyond that, we wanted to make sure that everyone can participate to the project as equals in an open collaboration. So we tried to embed in the DNA of the project this the fact that there is no one company that decides of the future of the project. It's really a community thing. So we added open development, which is this idea that everything that's happening within the open source project should be public and accessible to everyone. So open code reviews, open bugs, open blueprints, everything. Open design, which is the idea that you should not have a separate group of developers doing the design of the project away from the community, behind closed doors. Design should happen in the open and on the mailing list during events, in-person events, include everyone in the community, including users and not just developers of the project. And finally, open community. It's the idea that everything that's happening in development should be on a level playing field, that anyone can rise to leadership position regardless of which organization they might work for, and that contribution is the only valid currency in the project. You can't really pay your way into leadership positions. At that point, you might question why the choice of Python for this. So Python is first very easy to read, and so it's really easy to jump in the code and understand what it's doing. It's also easy to learn, so if you're coming from another language, it's not an extremely difficult situation where you have to ramp up your skills to actually be able to contribute. It's also easy to patch, so you can spot an issue, fix it in the code, and run the fixed code without having to resort to a complete, complex build system to actually be able to run that patch. It's also very well known by system administrators. Sysadmins are very familiar with Python in general, so it's our target audience for OpenStack. So it's a natural fit. And finally, back in 2010, Python was basically the only language that had extremely good integration with distributions. And I was also, in a previous life, responsible for packaging Eucalyptus for Ubuntu at Canonical. And Java is very badly supported in Linux distributions for reasons that are more for the fault of Java than the fault of the distros. And so switching to a language that would be easily integrated in distribution so that the packages of the project would be available through the regular channels of the distro was essential to the initial success of OpenStack. Another thing we had to sort out really early on was the API. Cloud services are basically just API servers that sit on top of virtualized resources. And there was a group of people that was adamant that we should just adopt the Amazon Web Services APIs. That basically was the de facto standard. It's not a standard, but it's the de facto standard. Everyone is using that. So you should just re-implement Amazon Web Service API. But we didn't want to do that because we didn't want to be inferior to whatever Amazon comes up with. We did not accept that Amazon would define what cloud means and what cloud is. So we preferred independence and come up with our own API and stick to that. And looking back at that decision 9 years ago, today it feels a bit silly because you have Google Cloud has their own API, Microsoft Azure has their own API, everyone has their own API, and everyone is fine with that. But back then, it was seen as like a very bad move for OpenStack to not adopt Amazon Web Services API. So that's how we started. 9 years later, what we ended up doing is a bit different from what we set out to do, which was pretty simple, small collaboration thing, and it grew to a lot of things. So that's a picture of all the components that are part of OpenStack today. It goes way beyond the Swift, the cloud files rewrite, and Nova, the cloud servers rewrite that we envisioned originally. The central box in this diagram is the main cloud services. So you have Nova and Swift, but you also have Cinder for block storage, Neutron for software-defined networking, Ironic to directly drive bare metal resources, or Magnum, which lets you provision Kubernetes clusters on top of an OpenStack installation. On the right, there is additional services that you can run to facilitate operations. On the left, you have the SDKs and client-side tools, but also bridges that you can use to plug other types of technology. Like Courier is a system that can be used to use neutron networking within containers. And finally, at the bottom is the various deployment tools that we support. And so they're developed within the community. So that's a lot of components, and those components saw massive adoptions. It ended up being very popular. Today, OpenStack is driving millions of CPU cores of computing power, which is the metric that is hard to relate to, but it's a lot of compute power. And it was successful in public clouds, especially in Europe, but mostly on private clouds. This is a picture with logos that gives you an idea of where OpenStack was adopted. That we know of, because obviously not everyone using OpenStack tells us they're using OpenStack. One of those logos is the largest company in the world in terms of revenue. Does anyone know which one it is? Walmart? Yes. So Walmart is running an OpenStack cloud to power their online retail, and it's 750,000 CPU cores of computing power. So it's a pretty massive system they have. So I guess that was too easy. Which is the #2 company in the world? There's just no way. You have to Google it. No, it's the State Grid Corporation of China with a very nice logo. It's basically the company that provides electricity to everyone in China. And they also sit on top of an OpenStack cloud to deliver their services. But we have no idea of the size because they are very secretive. So it's difficult to tell if it's a massive thing or if it's a small thing. The largest OpenStack cloud that we know of is actually at Oath, which is also a name you might not have heard of. Oath is the new name of Yahoo. When they got bought by Verizon, they got renamed to something that nobody can pronounce. They have something with weird names there. I don't know. Anyway, they're running an OpenStack cloud with 4 million CPU cores, and that represents 300,000 physical servers, which, even if you pack them into racks and data centers, is a massive footprint of computing power. And last example, the one I prefer, CERN. CERN is a research organization that runs the Large Hadron Collider, the largest machine built by man. And they're using an OpenStack cloud for nearly all of their computing needs, especially to absorb the results of the Large Hadron Collider when it's running, so that you have to have that computing and storage power behind the Large Hadron Collider so that you capture all the data from their experiments. And so their OpenStack cloud is 300,000 CPU cores and 1 petabyte of RAM, addressable RAM, which is a lot of RAM. And they're using it for 36,000 VMs and about 450 Kubernetes clusters. So they're running, using Magnum, 450 Kubernetes clusters on top of that OpenStack cloud. So that was massive adoption. Another thing we created during that time frame that we did not plan to create originally is a foundation. When we started, the project was basically owned by Rackspace. They had the trademarks, they had everything, control over it. And after a few years, it became some kind of a blocker for other organizations to join, that one company was actually owning the name and the governance of the project that they were considering contributing to. So there was this push to put those assets, common assets, into a foundation. And so we built, the team at Rackspace that was dedicated to OpenStack basically built a foundation, an open source foundation to support that and own those common assets of the project in a neutral organization. But we did beyond that, not just like asset lock. We also wanted to do a foundation that would also care about the downstream stuff, which is pretty common. That is marketing the software, running events, but also the upstream stuff, which is slightly less common. Usually you have open source foundations that care about upstream projects, so the open source project, or downstream, but having one that combines interest in marketing the results, but also make sure that the upstream open source project is in good health is kind of different from what there was there. So we created this foundation We also created a standard in open collaboration, because back in 2010, you wouldn't have so many new open source projects that would attract a large number of companies in an open collaboration. You had old projects like the Linux kernel, like Python, where you would have a neutral group of companies that would collaborate. But if you started a new open source project in 2010, it would be mostly the main sponsor model. Like they would have one company that runs the project and accepts contribution from others, but they still own it. And that standard in open collaboration was basically OpenStack proved that that model was still viable in 2010. And other projects, most famously Kubernetes, adopted the same kind of setup where they strive to maintain a really neutral ground for everyone to collaborate without any other company being in charge of the development. That ended up being a very active open source project as well. Like over the past year, the OpenStack project merged 65,000 changes, which averages to 180 changes a day, which is a lot of activity. That places OpenStack in the top 3. There's only 3 projects that are above 60,000 commits per year, and that's the Linux kernel, Chromium, the base for the Chrome browser by Google, and OpenStack. So it's a very active community. And to be able to absorb all this development activity, we basically had to build our own continuous integration system with lots of automated testing and lots of tests being run, because there is just no way you can maintain that velocity and keep quality without a very powerful CI system that basically tells you that everything is still working correctly. So this CI system ends up running 20,000 tests every day, and most of those tests deploy a complete OpenStack cloud and run functional tests for an hour. So it's a very significant setup we have here. And if you want to learn more about this and how we did this, there is a talk at 3 p.m. by Monty Taylor, which I invite you to see. The Zool software that he will be introducing there is the base of this CI system. We kept Python. We retained the use of Python despite various people wanting to use the latest language in vogue, like popular languages. Python is really great for integration, and cloud services are basically an integration layer, putting an API on top of other things. We don't invent like hypervisor or anything. We just connect APIs to virtualized resources. So I still believe that Python was the best choice, and if the choice was to be made today, I would probably do the same choice. Python has a very inclusive community. So the idea here is that basically Python and OpenStack serve each other. Like Python and OpenStack are stronger together. OpenStack benefits from this inclusive community in the Python community. It's really easy to engage in the Python community, to participate in libraries and join that community. It's also, Python benefits from all the testing that OpenStack does. I mentioned those 20,000 tests. We also pull new versions of Python libraries all the time. So whenever there is a regression that is introduced in one of those libraries that we use, we usually detect that regression moments after the Python library hits PyPy, like literally moments after the release appears. We run a test that will use that library in one way or another, and we detect the regression. We can feed it back into the Python library maintainer and get it fixed before it hits other users, which I think is a great symbiotic relationship there. We also created new libraries and new tools that are general purpose and not just dedicated to OpenStack. We contribute to existing ones, and we also adopted some abandoned ones that we happen to rely on. So I feel like it was a great relationship between the Python community and the OpenStack community. So that was a very wild ride, and during this journey, we learned a few things, and I wanted to share what we, as a community, did not know but learned during those 9 years running OpenStack. The first is that free software needs free tools. If you're using proprietary software to develop your open source project, then you're not completely free. You're basically subject to the limitations and the whims of the proprietary service owners. Like if there is a feature you need or a scale you need that the service provider, the infrastructure you're using will not provide, then you're stuck and you cannot grow anymore. And I would argue that OpenStack would never have grown to the size it is today if it had started on GitHub or another platform. But also on those proprietary platforms, you can be removed from the platform the next day. Like if you displease one way or another the service owner, their terms of service can ban you from the platform forever, and you disappear the next second. And with 180 changes a day, it's very costly to move to another development platform, and it basically stops development for a month or more while you migrate everything to a new platform. So it's a big risk for a massive open source project to start on one of those proprietary platforms. So for OpenStack, we ended up building our own open source project infrastructure using open source tools like Gerrit, like Zool that I mentioned earlier. And we operate this infrastructure in a very open way as a community to bypass this problem. Another realization is that we serve infrastructure providers. And what does that mean? Traditionally, you would represent applications like this, users on one side and applications on the other. But the way you deliver those applications has been evolving. 20 years ago, you would procure a few servers, install an operating system, your dependencies, and your application on top of that. But as time passed, we started adding more and more layers. The first layer was hardware virtualization, and basically you would run on a server. The server you would run your application on would be disconnected, abstracted from the actual hardware you're running on. The next layer was cloud APIs. Basically adding APIs that let you access those virtualized resources in a programmable way. And that's the age of the cloud. Basically, the cloud is provided, and you have cloud-native applications on top that can make use of this programmable infrastructure. And we keep on adding layers. Now, application deployment APIs is another layer, Kubernetes, that sits on top of those cloud APIs, that sits on top of virtualization. So you get the general idea here. You have this growing separate role within organizations of providing infrastructure for others to deploy applications and develop on. And that's where our focus is. It's on this infrastructure providing piece. We're not that much into the how do we use this cloud infrastructure. It's more how do we provide this infrastructure for others to deploy applications on. Another realization was that we build open infrastructure. We do not want a world where all infrastructure is provided by a couple of internet giants. We actually want that technology to be accessible to everyone, every company in the world, and not just Amazon, Google, and Microsoft. And it's important that we enable access to that technology. And open source, obviously, is the solution. So we focus on building those open infrastructure pieces in open source so that everyone can access this technology and not just a couple of companies. Another realization is that we should not build silos. It was really, at the beginning of OpenStack, we started with a very strong project focus. We're solely focused on the production of OpenStack software. And this project focus at one point was useful because it allowed us to really build this community, absorb all the energy that was thrown at OpenStack. But at the same time, after some time, this project focus starting to hurt more than it helped. When you have this very strong project focus, it's very tempting to expand, to have your project do everything, rather than collaborate with adjacent communities. And when a new technology comes in, it can be very difficult if you have this history of doing everything within your project and not collaborating with other communities. It can be difficult to engage with those new communities. And new technologies always come. And so that's a mistake we made with OpenStack. That's a mistake that others are making with other technology frameworks that are popular right now. And I hope that we will learn from history that it's better to collaborate early rather than build silos and expect everything to happen within your community. The last realization is that integration is the last mile. We have all of those great open source technologies, but the difficulty is really integrating and deploying them together. And it points to a lack of end-to-end testing. It points to lack of collaboration between those various communities, which makes that work extremely painful for every person that deploys them. And that really pointed to me to integration being the last blocker to further open infrastructure adoption. So at that point, we came up with a new strategy that we rolled out last year, which is basically a discussion shift from being project-oriented, building software, creating a solution, building a product, building OpenStack, to be more goal-oriented, like solving a problem space, integrating various technologies to solve that, and build or facilitate open infrastructure rather than just OpenStack. So, since open infrastructure is a bit fuzzy, we also had to explain what we meant by open infrastructure, or at least designate areas of open infrastructure that we would focus on especially. And we came up with a number of focus areas. A data center cloud is the space that OpenStack has been traditionally serving. Beyond that, we wanted to address edge computing. Like when you start distributing computing power closer to where those resources are consumed, it's obvious that interoperability and standards will play a very large role. If you start having compute capabilities everywhere you go, obviously you have to be able to go from one provider to another. So we think that open source has a great role to play there. It's a very difficult space because everyone wants a share of it, but I feel like we're trying to facilitate emergence of a common standard there. Container infrastructure is another of our focus areas. It's when you start integrating containers in open infrastructure, you kind of have to look at it end to end, from bare metal to the container, with a strong eye towards security. And that's where this container infrastructure focus area is about. CI/CD, obviously turning applications being written, code being written by developers into services consumed by users, and how to facilitate that transition. And finally, and more recently, we added artificial intelligence and machine learning, because those drive massive requirements. Like a lot of the compute power that we've been talking about until now, the millions of CPU core, a large number of those are actually used to power machine learning workloads right now. So how we facilitate this integration with machine learning tools is essential. Once we have those focus areas, we apply a strategy that goes beyond just producing software. We start facilitating finding common use cases. And I mentioned edge earlier. It's one of the things that are the most difficult to come up with in the edge space, standardize the use cases. Then we collaborate across communities. We try to find people that are already working on that space and try to get them to talk together. Then if there is any gap in the technology, we try to facilitate the emergence of a new open collaboration around this missing piece. And that's where new projects come in. And at the end, testing everything end to end, making sure that those integrations work well together. That's basically the new strategy of the OpenStack Foundation that we rolled out last year, no longer being only about producing and supporting the production of OpenStack, but helping open infrastructure in general by collaborating across communities. The projects that we support are just one piece of that puzzle. It's the missing pieces of technology once you start looking at those project focus areas. And ideally, the project that we end up supporting would facilitate multiple of those focus areas. Like OpenStack, obviously, can be used for edge or data center cloud or CI/CD. So it kind of overlaps with those various focus areas. Each of those projects would have specific technical leadership. We don't want to have everyone infiltrated to the OpenStack project. So all the pilot projects that we started over the last year are all having their own technical leadership and tooling. And now we've been starting those pilot projects, and we are looking into confirming them. Like pilot is more an experiment. We can see if there is an open collaboration forming around those new projects. And if there is adoption and people coming and not just one company or two companies or two organizations contributing, then it's time to consider confirmation and having a long-term relationship with those projects. So we have a number of pilot projects. The first one is Kata containers. It's a secure container runtime that combines the speed of VMs with the isolation properties of the speed of containers with the isolation properties of VMs. So basically have the security profile of a VM with performance that is pretty close to a kernel container. We have Zool. Again, there is a talk this afternoon. I won't go into much detail. It's a continuous integration framework that can reach massive scales through advanced features like speculative testing and cross-project dependencies. We have Airship. Airship is a framework to deploy open infrastructure. You basically declaratively describe what you want to deploy, and Airship goes and just makes it happen. Sorry. And the last one is Starling X. Starling X is an opinionated distribution of OpenStack that combines OpenStack and other open source technologies and based to produce an ISO that is suitable for IoT or edge or industrial use cases. So it's basically a self-contained OpenStack cloud that you can ship to integrate in machinery or that kind of stuff. Okay, so I wanted to end this talk with 3 challenges that we have today as a community, looking at the future. The first challenge that we are in today is surviving the hype. Hype is this interest that your project gathers when you have a new technology. People try to understand what it can be used for. They're trying to actively wrap their heads around that new technology. So that generates a lot of attention, generates a lot of participation to your project, generates a lot of attendance to your events, lots of press articles, lots of drama as well. And if you build, at one point this hype dies down. Like at some point people actually realize what OpenStack can be used for or what Kubernetes can be used for. And they realize, well, I don't really need to go to that conference anymore. I understand what Kubernetes does now. And at that point, the hype dies down. And if you build too much structure around this edge of abundance of resources, it's really difficult for a project to scale down. So we built a lot of things in OpenStack that were based on lots of resources being available, and now we need to change the way we structure the project to accommodate smaller number of developers. Still a massive number of developers. We still have thousands of people involved in any OpenStack release, but it's no longer 5,000 or 6,000. And so the structure you put in place to handle 6,000 developers does not necessarily work well when you start scaling down to a more reasonable number of developers. The second challenge, and it's connected, is getting users more directly involved. During this hype phase, you attract, for development, you attract large service companies like IBM or HPE, and they would throw large amount of resources at you. But at one point, those companies realize that they do not necessarily have a business model around that new technology. They've just been throwing resources at it in case, somehow that makes them relevant. And at one point, those companies, most of them, will realize that they don't have a valid business model around the technology, and they would pull those resources out. And at that point, you need to rely on your real users, the people that actually benefit from the technology, the direct users or companies that actually have a business model around your technology. And this transition from being hype-driven to user-driven can be also a bit difficult. And we're in the middle of that transition for OpenStack now. And finally, promoting our model. I said earlier that we believe that free software needs free tools. And that means we're not using GitHub. And today, most of the open source development is happening on GitHub, not necessarily on the largest projects. If you look at the 3 projects that I mentioned, Chromium, the Linux kernel, or OpenStack, none of them are on GitHub. But still, there is a lot of developer familiarity with the tooling of GitHub and the workflow. And so having a different workflow is kind of a difficult bump for new contributors to jump in. And so to promote our model, to educate people to how the collection of open source projects that we use for project infrastructure can be used, we need to do more education. And so we've been starting to establish a new effort called OpenDev. OpenDev is basically taking the project infrastructure that we built for OpenStack and make it available, more obviously available to every project that want to join to reuse that infrastructure under a name that does not imply you become a part of OpenStack. All of our project infrastructure used to be under openstack.org, so it was difficult for people to realize that they could actually add their projects to it. So we've been starting to rebrand the project infrastructure under this OpenDev brand. So that concludes this talk. I hope that you will join us on OpenDev, and I hope that you will also join us to openly develop open infrastructure. Thank you.
Thank you very much. Thank you, Thierry. Alrighty, I think we have some time for a short Q&A. Now, earlier on I mentioned that there was an app. There isn't an app apparently. There is a QR code that we'll put on the screen in a minute, and you'll also see the QR code which is stuck to the walls on the edge of the hall. Use that QR code to submit your questions if you like, but while we do that, I'm happy to take people's questions just by raising your hand for this first time, and then hopefully we can get the tech sorted for the next time. And we'll get our next speaker queued up while we take questions to Thierry. Who wants to throw a question? Just raise your hand, I'll run up. I've run up these stairs so many times. It's my fitness. Someone from the back, perhaps? No questions? Yes.
Hi, Thierry. I'd like to ask, how is it all funded? All these years of development that you mentioned, and what are the economics behind it?
So your question is, how is the OpenStack Foundation funded? Okay. So it's set up as a nonprofit, as a trade association. So that means you have several companies that can be members, and that's how we derive most of our funding. We also run events, but the events are not really profitable. It's like so we have a number of companies that are platinum sponsors, and so they get one permanent seat on the board of directors. The board of directors is mostly how you spend that money. It's not involved in technical decisions or anything. So it's like a pool of money that is funded by a number of companies that have interest in seeing OpenStack succeed. So we have, Intel, for example, interested in general usage of cloud technologies because it sells servers, and so they are one of the sponsors. AT&T is a very large OpenStack user. They have, I think, 200 data centers around the world that have are used for the local services that they deliver to their users. Also, all the 5G that they're deploying is based on OpenStack. And so obviously they have interest in keeping the project in good shape. So AT&T is one of the other platinum sponsors, and that's how we fund the foundation itself, knowing that the foundation is less than 20 people, so it's not a very large organization. It's not like a Linux Foundation size or anything.
Shall we take one more? Any more questions? Yes, down here, down here. The microphone is coming to you right now.
We all know the advantages of open source in this initiative. What about the disadvantages, especially in the context of a big company like Nokia?
So the question is, what are the disadvantages of open source? I'm definitely not the right person to answer this one. I can say one drawback of the open collaboration that we've set up in OpenStack, and we're seeing the same problem with Kubernetes, basically walking the same track, is that sometimes the project gets too big. It's not, you can tell that there is no product manager on top of it, so that it tends to spread to something that might not make sense from a marketing perspective. And so it's difficult to consume by organizations because it's just sprawling thing that does too much. And I wish we would have now the experience to see that having a very strong opinion on what your project does and does not do would really help open source projects, because naturally it's difficult to say no. Basically, you can't really reject a feature when you're doing an open collaboration. Like, oh, you're nice, you come to us, and here is your feature, and it's like, thank you. And you have to accept most of it. So saying no is very difficult, and sometimes you should say no for the sake of keeping things simple and deployable and upgradable. And so yeah, that would be the drawback. And choosing a project that have very strong statements in terms of what their project will do is, I think, a way to fix that. But generally, open source project, especially openly developed open source project like OpenStack, tend to fall into that trap of, oh, let's do everything.
I'm told we have a question through the app, which means it works. Does OpenStack have two questions? Have a steep learning curve? And second question, does OpenStack have second question is the same as the first question? Well, apparently it works well.
So OpenStack has double steep learning curve. I would say that it's providing infrastructure is obviously not something you do like a hobby, and it makes OpenStack sometimes difficult to grasp because it's a complex set of software, and because the problem we are trying to solve is complex, and sometimes yes, there is a steep learning curve to OpenStack. Education is good. Like Python makes it easier to jump into the code. We're trying to get better at documenting this initial step of diving in, but it's a complex problem space. But what we realize is that when a project deploying, an organization deploying OpenStack fails, it's generally not due to the software or the complexity of the deployment. It's more a cultural thing. It's generally that organizations are not necessarily ready to switch their organization model to a cloud-based system where basically people providing infrastructure are separate from the people deploying on that infrastructure. It's a shift. It's very difficult. It's like going from traditional development to cloud, but within an organization. So what we're seeing is usually that it's the social transition of the company that just doesn't work. Like the traditional IT department resists deploying OpenStack because that means everyone will be doing IT now, like consuming IT. I want to be in control of that. Well, you're no longer in control. Like your department is only providing infrastructure now, and everyone can consume it the way they want. It's like, no. And so sometimes you get into those social issues within companies, and the project dies, not because of the technology or because of the steep learning curve, but because the company was not ready or willing to undertake that type of change.
Thierry, thank you so much for that awesome talk. Thank you very much. I appreciate that you were here. Everybody.